Hello, everyone. Thank you so much for sticking a bit more and staying until the end of the day. Also, thank you so much to Ella and everyone that made sure that we're super cozy and fed during the day. I've been here for 4 years already, and this is my 4th edition, and every DeSci Berlin is the time where we reflect on everything that we learned this year, and we showcase all the progress made. So I'm really excited to show you what we've been building. My name is Maria Sanmartin. I'm a senior product manager at Molecule, and today I'll present Molecule Labs and the product experience that we are building. Obviously, I'm here to present the amazing work that the entire product and dev team that is there was able to create, so I'm just here on their behalf. Nice. So, during my presentation, I'll basically build on top what Paul already presented, Kevin and Phil shared as well. And I'll dive deeper into the interaction layer that basically builds on top of our protocol, which is Molecule Labs. I'll share some insights and core learnings that we made through the years, and basically just so you gain an understanding of how we got here and why we're building the things that we're building, and the way that we've just been kind of gathering learnings and just building iteratively through the years. I'll share the thesis, and also I'll just explain slightly better how the stack is built and how it works and how things interrelate to each other. And then I'll present a couple of flows, so for the researcher, for the AI builders, and for the funders. Yes. Good. So, as I said, this is my 4th year at Molecule, and in the past years, we've been building so many different experiments to validate many different hypotheses. And, I want to kind of take some time to go back in time and just reflect on the hypotheses that we validated and things we've learned and the things that we built and how we got to the place that we are. So, through the years, the only thing that remained constant is that for Molecule, or our vision is to make sure that we accelerate the pace in which science gets discovered, funded, run, and that also we make sure that brings cures and breakthroughs, important breakthroughs to the world, and also derive value at the end back to society. So that's the only thing that we remain constant, but if I look at all of the things that happened through the years, in 2023, the core learning is that we validated that yes, crypto can fund and does fund science. So that was a very important year because during that year, we saw how communities of science in different disciplines raised large amounts of fundings using blockchain-based tools, using our products and our primitives, and the things we basically built. We also saw how individual and anonymous funders were able to fund and govern IP, and also be able to participate in these research projects via the distributed communities that are called DAOs, and you've probably heard about them. We call them science DAOs. They are decentralized autonomous organizations. We also created a novel token type that was basically signifying property rights from real life on-chain, and we call that intellectual property NFT, or IP-NFT. And it was pretty cool because basically it was able to assign ownership rights to an asset on blockchain and also in real life. So during that time, we designed and built a launchpad, which is basically a platform that allows a token auction and enable the creation of these tokens, the distribution, and the setting up the prices for these token communities. And the really cool part that happened is that we saw how many groups that care about psychedelics, women's health, hair loss, longevity, many kind of scientific communities were able to raise big amounts of capital and start to already run the science and find projects that they were willing to support. Then in 2024, that was an important year because that's when assets became tokens and vice versa. So we saw that the communities that got funded previously coordinated themselves using Web 2 and blockchain-based tools, so something that we call Web 3 tooling. And they basically organized themselves, hire researchers, hire industry experts, hire pharma advisors, and basically embedded these decentralized teams into the organization to basically scout for projects, run due diligence, deploy capital, and follow up on the different research initiatives. The thing that happened that year also is that these communities were struggling to report back to funders and to the community the progress made by the different projects. And the access of data was still an issue. So the same kind of thing that we were seeing in private companies, but we're also seeing in this like decentralized distributed tools. They still were keeping data siloed. We also saw this year, thanks to the things that we built, that individual research projects for the first time were basically able to raise funds for independent projects. And this was very interesting. At the end of the year, we created a platform, this like token auction platform, that enabled individual researchers to set up their projects, and within a matter of days and hours, we were able to fulfill the fundraise. So it was quite extraordinary to see that blockchain, again, just revalidates that it's a great space to be able to raise funds and deploy capital. In this year, the individual and anonymous funders, the only issue we saw is that they cannot directly deploy funds to the projects themselves. They always need a legal entity in the middle that can deploy the capital to institutions. So that was like a really important learning. And also we saw that the existing token model did not really provide enough value to early funders, and that mostly early funders were either speculating on the token or treating it as a philanthropic exercise, so they were buying the tokens, not really expecting that much back. During that year, we created project tokens and also set up the contracts and the products to enable what we call crowd sales, that are token-gated token sales, and also we started to draft our coin-to-company model. Now we fast forward to 2025, and this is a time with like AI exploded, and we started to see AI and agent-powered workflows in all sorts of disciplines, so in productivity, in ops, in personal life, and in specialized industries. We saw that really powerful models were generally available and became mainstream, and the blockchain infra also started to be the best testbed for these AI examples. We also saw last year that thousands of agent-related projects raised large sums of capital, again in crypto, even during bear market, which is quite extraordinary. So we had agent-related projects that raised millions last year. So also something worth observing and worth learning about. So we definitely took that learning and started to embed a lot of AI tooling. We developed our coin-to-company model, so we finally had something of value for funders that supported early research and something that allows them to stick and get value straight away from the project. And the issue through the years remained the same. We were struggling, and the projects were struggling, and the communities were struggling, and the DAOs were struggling to get information back from the science projects they funded. So science reporting was not happening, and early funders did not have access to the underlying data and the underlying value of the research project. So we decided to start building the data infrastructure for this, and started to explore and pivot a bit the different products so we can enable that to happen within our stack. And then fast forward to today, this year hypothesis, and it is a statement, but the reality is a question. It's like, can science run autonomously? And that's the question that we have in our heads and where we're trying to test this year, because we're seeing that there's extremely powerful and specialized solutions that are available now for teams and for companies to be able to run workflows, either with this setup of like a hybrid and like a human plus an agent, so a hybrid setup, where they're running different parts of the workflow for discovering projects, for funding projects, for doing drug dev, and also AI is providing like novel inventions. We're also seeing that global AI and science-specific governance is still a work in progress, so we'll see what happens. And we're seeing that tech giants are recruiting life science researchers all over the world, and they're just onboarding them, right? So I think it is a critical point, and I think that we're now at a point where it's, we can't really shine if we put enough attention and put enough care into the things we're building. So what we did, we basically enabled the data infra layer and enabled programmatic functions. So everything we did before and that was human-led now is for agents and for systems to be able to use it. Data sets and experiments and report and the critical updates are still non-accessible. And that's why Phil's presentation is so important, because for the first time, we dedicated an entire year to build a primitive that would enable this behavior to exist. So basically, we have an account, where the treasury can live, and also the program rules to then enforce the reporting mechanisms needed in order to give early funders visibility of the progress made in the research, and also to inform future funders of the underlying value of your research. So all of a sudden you can present your project to the world and give back information to either early funders or future funders. That said, through the years, we're in the business of trust at the end, right? And trust needs to be earned. And for us, a lab is the place where you can start, especially now that we have an on-chain lab underneath. We have these labs that are programmable. So basically, rules can be set between the researchers and between the funders. And then payments can happen, and the desired behavior can run within the accounts. Accessible, meaning that anyone, contributors, researchers, funders, builders can access the space. Can access the space and really get into the project by accessing the data layer, verifiable. So every single action that an actor performs in the account, even if it's a researcher, an agent, a payment, gets recorded, and someone can just go and verify every single step. And the accountability piece, right? That's, I think, the core part to be able to build trust, is that we are finally having two parties and the system and the tools to make sure that the behavior it really performs in the way that we want it, and that the system is accountable, not like what is happening today. Because the reality is that many crypto projects that are raising funds, they're not accountable because there's no rules enforcing any mechanism for them to perform in a certain behavior. Let me check. Yes. So our stack, like Phil already presented, we have the protocol, which is the foundational layer, human governed, and we obviously audit it, and is where the core primitives behind the account for the lab lives. And then we have Molecule Labs, and Molecule Labs is a product layer that basically leverages all of the functions from the protocol. So it's a mirror of what is already there. It's just the layer where humans can interact with it. So it's the element where the entire world can interact with the protocol, and it's a way also to showcase the different features and the value that the protocol currently has. One important piece is that because we developed this data layer and an API, for us now it's really easy to access the underlying data available in each of the labs, and that's how we build our product layer. I invite you all to go check molecule.xyz and explore projects. That's basically the layer where you are going to interact with Molecule Labs and also with each of the projects and with the underlying data infrastructure. We also started to play with different agents and built an example that is called MIRA. And it's our own instance of an agent that basically gets data from a lab, runs a project evaluation framework, and provides an assessment and a signal to funder of the underlying value of the project that they're seeing and where the project is in the readiness level, as well as the progression they're making with the money that they've been given. To showcase how Molecule Labs works, I'll just go through the different journeys. So for the researchers, so here we have the researcher role, and the way that we're looking at it is they can be human researchers, aka scientists, they can be lab operators, and they can be agents that behave as researchers. And for this group is quite easy. You can set up a lab. It takes minutes and seconds to just set up your lab, set up your project portfolio, and attach a data room. After you do that, you can add your contributors. So if you have in your lab or in your team several researchers, you can add them as contributors, and they'll be able to submit files to the lab. And you can also set permissions, depending on if you want them to be a contributor or only a viewer. And then you can link also the token community or the project token that you already have, because that could be the access token as well, to be able to give a chance for people to access specific information in. The second step is just as easy as dropping files into the lab, submit decks, data sets, experiment results, key milestones, basically everything that the project has produced can go into the lab. Everything gets versioned, time-stamped, and also it's permanently stored. The different, the contributors can decide whether that piece of information is public or confidential. If it's confidential, it will get encrypted. And in both cases, the action that happens within the lab generates a public record. So on the other side, on the external side, we created a discovery layer. So every time you create an on-chain lab, you're going to create a project page that is visible and public for everyone to see. And what is really cool, that every interaction in that data room is going to get an action in your timeline. So whenever you fill your data room, you make progress, maybe once a month, maybe once a week, everything is going to be represented. If the file is confidential, you're going to get an item, and obviously the file won't be visible unless you make that actor a viewer in your system. At the end of the day, we are setting up a system that enables trust. So we want funders, either early funders, future patients, people interested in your research, to get closer, understand what, the exact track record that the project has, and verify it by themselves. So basically, they have a way to consume information about your research project, progress made, and they can dive as deep as they want into the files and into the reports created and into absolutely every single detail to fully understand the underlying value. To showcase the UI, just so you guys have an example, very familiar UI is like a researcher portal. You create a lab, you get basic description of your project, and you drop files. Also, the cool part about this works via an API, so you don't need to manually do this. You can have several systems submitting information for you. Or maybe you work with other set of tooling, you can just send data directly to this lab. So super easy. You don't really have to know anything about blockchain. We're kind of making it quite familiar for anyone to use. Then I want to share with you an example of an agent that we built that basically leveraged that public information from a research project. So we called it MIRA, which is Molecule Insights and Research Agent. And what it basically does, it takes information stored in this lab, public information. We've created a skill. So basically, we've created a skill based on a project evaluation framework that takes public information, run a set of operation, and then gives back an assessment to inform the public where your project is in the technology readiness level, and then what's the assessment of the project progress in an 8-dimensional project scoring framework. So this is really helpful for people that either don't have time to go dive into all your decks and all of the data created and all of the reports, and just get like a high-level understanding and early, this is worth my time signal to then dive deeper into the project. We also created an MCP and a sort of chatbot. Then the cool part is like, I can use this tool via Claude and just call the MCP and already get information about all of the projects that are available in Molecule Labs. So I can ask questions about, hey, what's this project about? Is the project progressing? When was the last update recorded? And get all of this information either by using our product, molecule.xyz, or also some of these like AI tools that we have built. The cool part about this like AI builder side is we've created this loop that takes data from the lab, runs the assessment, and then displays this information in our product. But there's so many other kinds of agents one can build with their data available in the lab. So you could have your own data, create your own agent to run some like computation analysis or like some, knowledge graph across all of your project portfolio to fully understand interrelationships or who knows what. I think it's the opportunity also to be a bit creative and think about how to use the API and the MCP to potentially build your own scale, build your own agent. Nice. And lastly, for funders, so for us, like I mentioned before, is what happens outside that lab, right? At the moment, a lot of this research progress happens in closed doors, even to the general public. We're co-funders of very important research and breakthroughs, and we don't really have access to any of that progress. So the system that we're trying to create here is a system where science runs in the open space while making sure that important secret information remains private and encrypted, right? But it gives access to people. So in this other side, which is the public side of your lab, funders can get to our discovery page and find different assets, different projects that are available in lab, and just discover like early stage research that was, before it hits mainstream, and they can be like early funders. They can check progress, so review the project timeline, all of the activities, the decks, the updates, and like I said, every nitty-gritty detail about the project can be just reviewed, and even request access to see confidential files. And the last step is to actually verify its value. So it's like, is this thing worth my time? Is this worth my effort and my money? And that's something that can happen quite quickly compared to the current workflows in which they need to go potentially to universities and talk to TTOs and then demand all of this kind of information. We would just want to make it available from the get-go. And the last step, and it's something that we've integrated with existing projects that already got funded, is that if your project fundraised in the past or is about to fundraise, we also give a kind of call to action to join the future fundraise, or if the project fundraised and it has a liquid token, you can directly buy the token. And many of these projects have already a mechanism to get money from trading fees. So it's quite cool. You buy the token, or your future funder buys the token, and that creates two benefits. Your token price obviously increases, but also you're getting fees for fees for every transaction that happens. How that looks, I'm just showcasing here the project portfolio. So we have a discovery landing, which is the Explore project page. We have portfolios, which is a way for entities, organization, groups to basically set up their portfolio of projects. And then we have project pages that include basic information about the project, the assessment run by our agent, a timeline of activities, and also the token layer. So if token is available, they can directly trade. So I'm kind of biased, but I'm really proud to where we got, because we've been working on very isolated POCs, and now we're creating a very foundational ground for us to keep growing. And I have a couple of asks. If you're a researcher, just go to labs.molecule.xyz, try to create a lab, see how it works, share your feedback, test, submit some files, get your public page going and see what happens. If you're a funder or an organization that already funded projects, test a pilot, see how projects behave. So ask the researchers, create the projects, bring them as contributors, and then test how the accountability layer works and see how projects report, and then how funders perceive the reporting as well. And if you're a builder, we have a pretty composable set of tools, so you can just check out our docs or join our Discord, ask some questions, and get an API key and have some fun with some of the things that we've already built. I think that's all. So it was a big pleasure to be here today to share what we did with Molecule Labs, and thanks to the protocol. If you're curious to learn more, just reach out. We are going to be here today and tomorrow. And before I go, I just want to give a huge shout out and a round of applause to the Molecule product and dev team. So Vlad, Noor, Tom, Ella, Kevin, Phil, Jan, Jonas, everyone that made possible what we've done. Thank you so much.